Hello, a Rosie math teacher coming at you from my second period accelerated grade 7 math class, where today we are working on lesson 4-5. It is a begin day. Yes, time to think about it. We're talking about one solution, no solution, infinitely many solutions. I did begin with no solution. If you solve an equation that ends with something like 4 equaling 0, that's nonsense. If it's nonsense, it's not possible. If it's not possible, it's no solution. Not that difficult, okay? So the example I gave was 4 equaling 0. That cannot be. So it's a what? No solution situation. Then in your notes, you've also written about one solution. It is one solution if it's the type of two-step equation we have been solving. So for example, we get to the end where x conveniently equals 5, or x equals 1/2, or x equals 4.4. Whatever it is, if there is a definite amount that x is equal to, we will say it has only what? One solution. Infinitely many solutions. If you end with something like 2 equals 2 or 8 equals 8, etc., it is infinitely many solutions. I'll give you an example. You solve 2x plus 2 equals 2x plus 2. Guys, do we end up with the exact same amount on both sides? Yes, because I said the same amount on both sides, didn't I? So if we have same number equaling same number, the example I gave you here, there are 2 of them. If 2 ends up equaling 2, that means infinitely many solutions. Because it would not matter what we put in place of the x. In my example of 2x plus 2 equals 2x plus 2, if you put 1 in place of the x, 2 times 1 plus 2 would still equal 2 times 1 plus 2. If you put 100 in place of the x, 2 times 100 plus 2 would still equal 2 times 100 plus 2. So do you see how it would not matter what number you put in place of the x? It's going to have infinitely many solutions, meaning infinitely many different numbers we could put in place of the x, and it's still going to be the same on both sides. So we need to keep that in mind for today's lesson as we begin with item number 1. I will write it on my screen. My students will write it on their note-taking page. Does, and I will copy this larger so that you can see it easily, does 4 sets of x minus 8 plus 12 equal 2 sets of 2x minus 9? My 9. Short and sweet. Okay. Please copy 4 sets of x minus 8 plus 12 equals 2 sets of 2x minus 9. Class, we're going to go ahead and solve to see what happens on both sides of the equation. Then we will compare to our notes page to see if it is one solution, no solution, or infinitely many solutions. Let's go. What is 4 times x? Say it. 4x. It is not challenging, y'all. Just 4x. And then 4 times negative 8. Say it. Negative 32. Yay! Negative 32. Now, when we say negative 32, is it okay that it gets written as minus 32? Is this good? Yes, this is good. Excellent. And then I need to remember to copy what? Plus 12. I'm noticing several of my students suffer from the same thing I do. And sometimes, for whatever reason, my brain will skip copying down the plus 12. When I'm done with the parentheses, I'm like, yay, I'm done with that side. When I'm not. So please be aware and make sure you don't forget. 2 times 2x. I'd love to hear everybody. 4x. And then 2 times negative 9. Negative 18. And it gets written as if it is minus 18. And that is okay. Now go over to your left-hand side and ask yourself, is there anything on the left side of the equal sign that I can combine as like terms? Name either coefficients or constants. What can I combine, class? Constants. Love that answer. So on your calculator right now, type yourself a negative 32 plus 12. Raise your hand when you have an amount. Yes, ma'am. Negative 20. Who agrees with negative 20? And let me write that in black so that you guys can see it on that screen. And then what is the amount of x that I will now recopy in front of negative 20. Please say it. 4x. 4x take away 20 equaling 4x take away what? 18. So guys, do I have the same amount of x on both sides? Yes, so let's follow through with the procedure we've been doing. Undo the value of x on one side and undo the value of x on the other side. This is looking strange, isn't it? All right, so my x values cancel out. My x values cancel out. What is the only thing to bring down on the left? Negative 20. What is the only thing to bring down on the right? Now, please refer back to your notes. If you have two different amounts that claim to be equal to each other, does this make sense or is it nonsense? Nonsense. And remember, we talked about if it's nonsense, if you solve an equation that ends with a number equaling a different number, that cannot be. So it's what, class? No solution. Please write yourself a note that when you begin your homework, item number 1 will be a what? No solution type of problem. Are we understanding so far? Thumbs up if we're getting this so far. It's really not that bad, is it? It's just more practice solving equations, and then you compare to the notes that you made. Let's go to item number 2. This time it says, does 3 sets of 2k minus 5 equal 6 sets of k minus 4 parentheses plus 9. You remember what I said earlier? Don't forget that little extra piece, plus 9. All right, now at first glance, we really don't know if this is one solution, a solution, or infinitely many solutions. So we're going to begin by removing the what? Parentheses. Remember, this is distributive property, so it means 3 sets of each piece inside the parentheses. 3 sets of 2k, 3 sets of negative 5. So if I do 3 times 2k, what amount of k? 6k. If I do 3 times negative 5, what amount? Negative 15. Excellent participation, guys. Equaling 6 sets of k. What is 6k? 6 times k? 6k. I said the answer. All right, what is 6 times negative 4? Anybody? Okay, I have some people saying 24 and some people saying negative 24. Which is it? Negative 24. So it appears as minus 24, yes? And then what do we still copy? Plus what? Plus 9. You got it. All right, do I have a side left or right where I can combine like terms? Class, to the left or to the right? To the right. Thank you. I have to turn around and see how it looks in your view. All right, so this side. Am I combining coefficients or am I combining constants? Constants. What am I typing in my calculator? A negative 24 plus 9. Please raise your hand when you have an amount you would like to share. Yes, ma'am.
Negative 15.
Who agrees with negative 15? Do we agree? Yes, we do. All right, and then what am I copying over here? 6k. And on the left, 6k minus 15. Now, guys, I know we can probably already tell, but let's go ahead and solve by undoing the 6k. What amount of k will I subtract on both sides? Minus 6k. Minus 6k. So what amount am I left with on both sides? Negative 15 equals negative 15. Hey, samesies. Negative 15 equals negative 15. Look back at your notes, find your example. So is it no solution, two numbers that are different? Is it one solution, x can only equal one amount? Or is it infinitely many solutions where you end up with the same amount on both sides? Class, say it. Infinitely many solutions. Now let's go back and try something. So for example, when I had my 6k take away 15, I want you guys to see what this means. So let me recopy it for a moment. 6k, I'm going to put parentheses there, minus 15 equals 6k, I'll put parentheses there, minus 15. So guys, if I put a 2 here, what is 6 times 2? 12. Take away 15, would I land on negative 3? Yes. And so if I did 6 times 2 here, what is that? 12. Take away 15, would I land on negative 3? So I would have negative 3 equals negative 3, wouldn't it? What if I put 6 times 20? 6 times 20. 6 times 20 is 120. Take away 15, what would I get? 105, yes? Okay. And then equals 6 times 20, 120. Take away 15, what would I get? 105. So again, I would have the same number equaling the same number. Guys, it won't matter. It's infinitely many different numbers, so infinitely many solutions are possible, and they will always end up with same on the left as same on the right. Are you following? All right, let's go ahead and proceed to an item that I think might be a wee bit more challenging. Let us try item number 5. I want us to go straight to item number 5. They want you to complete the equation so that it has infinitely many solutions. Hey guys, we just did a problem like that, didn't we? So what is our goal? Do we want the right side to have the same amount of x and also have the same amount of a constant over here? Do you agree we want it to match what the value is on the left? All right, so let's begin by copying what they have given us so far on the left. And again, this is item number 5. So item number 5, label it in your notes. And then please copy 2x minus 7 sets of x plus 10. We need to combine everything that we can so that we find the total amount of x that we want to place here and the total amount of the constant we want to place here, so that both sides will be representing the same value. All right, so let's begin. 2x take away 7 sets of x plus 10. Guys, please recopy your 2x down below in your new row of information. And then what shall I multiply here? Negative 7 times x. What will that give us? Negative 7x. Is it okay if it now shows minus 7x? Yes, that is good. Next, I will multiply. Negative 7 times what? What does that equal? Say it. Negative 70. Is it okay if that now looks like minus 70? Yes. What is my next step? Combine like terms. Am I combining coefficients or am I combining constants? Say it. Coefficients. Wait a minute if you said coefficients. You are absolutely correct. So I'm combining my positive 2x with my negative 7x. Use your calculator. 2 minus 7. Raise your hand when you have an amount. Yes, sir? It is negative 5. Now, very important and legitimate question. Do I need to put the variable x here? Yes or no? Yes. I have seen some children who keep forgetting to then copy their x. Please don't forget that. you are finished with those x values, what shall you now copy? Minus 70. So do we now know what we wish to place in that first box? Now they gave you the x. So what am I writing in that box? Say it, please. -5. You are correct. They've given you the x. So it's -5x. Now this is interesting. They say plus. What did we say? Minus 70. Guys, does plus -70 mean exactly the same thing as minus 70? Yes or no? Yes. So in the blank, since they have given us a plus sign, we must write what amount here? -70. And once you have written that, do you agree it will make both sides represent the exact same value? So no matter what number I put in place of x, when I do it on both sides, will I get same number on the left, same number on the right? Yes, I will. I hope this helps as an introduction to today's lesson. Bye, guys.